Alright guys, so we're going to write down our steps for how to multiply fractions with negatives. And our first example is going to be 3/5 times 5/6. And I'm going to make the 5/6 a negative 5/6. So 3/5 times a negative 5/6. Now, adding and subtracting, we worried about our integer rules first, correct? Multiplying and dividing, when do you think we're going to worry about our integer rules? Last. We're going to pretend they're not even there. So it's the very last thing we will do will be our integer rules. Is that understood? Okay? So, there's two different ways that you guys can technically solve multiplying fraction problems. But I'm going to teach you one way, and that is the way that I want you to practice and use, because it will make life easier for you, especially when numbers get to be really, really large. Okay? So, when we do this, and we are multiplying fractions with negatives, our first step is to do something that's called cross cancel. Has anyone ever heard of that? Okay? We've used cross multiplying before, right guys? Okay, so we've cross multiplied, now you're going to cross cancel. Cross cancel is what means when we say cross divide or cross simplify. So what I mean by that is you're still looking at your numbers that are crossed from one another. For instance, 3 and 6 are crossed from one another. Does that make sense to everyone? Now, instead of multiplying them like we did when we cross multiplied, we want to simplify, meaning I want to divide a number out that goes into both. So what number goes into both 3 and into 6?
3.
So I'm going to divide each of these by 3. Because I want to divide out, I want to take out, I want to get rid of it. So 3 divided by 3 is 1. So I'm going to cross out the 3, and my new numerator is a 1. That 3 goes away, and I changed it to a 1. Does that make sense to everyone?
Yeah.
I'm going to do the same thing with the other one. 6 divided by 3 is what?
2.
So I'm crossing out the 6, and I'm putting a 2. That is my new denominator. So new numerator, new denominator. Does that make sense to everyone? I'm going to do the same thing with the other side. I have a 5 and a 5. What can I divide out of both 5 and 5?
5.
So I have 5 divided by 5 and 5 divided by 5. 5 divided by 5 is what, everyone?
1.
So those 5s are going away, and I'm left with 1s. So I have two new numerators and two new denominators. Does that make sense so far?
Yeah.
Okay, step 2. Multiply the numerators. What are my numerators, everyone?
1.
And what's 1 times 1?
1.
Step 3. Multiply the denominators. What are my denominators?
1 and 2.
And what's 1 times 2?
2.
Whenever we finish with fractions, we should always make sure it is in what form?
Simplify.
So simplify if necessary is step 4. So make sure you always simplify. And then what's our last step going to be, guys? Is it positive or negative? And I'm literally going to write it down like that. Is it positive or negative? And in this case, guys, is it positive or negative?
Negative.
Why is it negative?
Negative difference.
Good. One was positive, one was negative, so my answer has to be a negative. Cole.
Couldn't you have just done the 3 times 5 and 5 times 6 and simplified?
Could I? Yes. But do I want you to do that way? No. Because, what if I were to give you some really, really large numbers? To me, it's a lot easier to simplify before you multiply than to simplify in the end, because your numbers are going to be smaller. It's going to be a lot easier when your numbers get to be really large numbers that you can simplify first. So I want you to get used to this method. But yeah, otherwise, you can multiply your numerators, multiply the denominators, and simplify. Absolutely. Okay, let's do another example. What if I give you negative 3/4 times negative 12? I'm not going to write this down as a step, but what's the first thing I have to do here, Autumn?
You have to put 12 in 1.
I have to put a 12 over a 1. You have to make your whole number into a fraction, and any whole number made into a fraction is always over 1. That would be the invisible math rule, guys. If you look on the back wall, it's that top orange one. There is a denominator for every number, so the number 3 equals 3 over 1. That's always the case. No matter what we're talking about, that's always the case. It's invisible. You don't see it, but it's always there. Alright, now what should I do?
Simplify.
Cross divide.
Cross cancel. Can I cross cancel 3 and 1?
No.
So is it okay that numbers stay the same?
Yeah.
I do not have to cross cancel. If you can't cross cancel, you leave them alone. Is that clear? Okay. 4 and 12. What can I take out of 4 and out of 12?
4.
So 4 becomes a what?
A 1.
A 1. And 12 becomes a what?
3.
Step 2, what is it? Well, what are my numerators?
3.
And what's 3 times 3?
9.
What's step 4 or 3? What are my denominators?
1.
And 1 times 1 is?
1.
And 9 over 1 is just what?
9.
9. Please make sure you give me 9. Don't give me 9 over 1, even though they mean the same thing. Get in that habit of just putting it as a whole number. So that's essentially my simplifying right there. By taking that 1 away, you simplified. Is it positive or negative?
Positive.
Oh, positive. Negative.
They're both negative, so it's going to be a positive. That'll be a little bit, here's the deal. When you do these problems, it's really easy to mess up the negative or positive part because you're like drawing over them, right? So I would encourage you to rewrite every problem you do. That way you can look at the original problem and check your work and make sure it's negative or positive. Questions on this at all? Ready to practice?
Yeah.